All right, what I would like to do now is transition to linear inequalities. Now, there are two categories of inequality symbols. So first you have is strictly less than, is strictly greater than. These are strict inequalities. And then your non-strict inequalities will be is less than or equal to, or is greater than or equal to. Two categories, strict inequalities and non-strict inequalities. All right, let's jump straight into an example. Now, this example says 4 times 2x minus 3 is strictly greater than 4. Now, there's a couple things I want to say. The way you solve an inequality is exactly the same way you would approach solving an equation, with the exception of two things. Number one, keep the variable on the left side of the inequality at all times. So you always want to keep the variable on the left. Now that's not mandatory, but it is a strong recommendation by me. I think things get a little bit confusing when the variable's on the right. So keep it on the left if you can. And then you always flip the inequality symbol. You do that whenever you multiply or divide by a negative number. Okay, so you have to keep track of those two things. Now, I'll be honest with you, this second rule here is easily forgotten by students, so please keep that in mind. All right, so let's go ahead and solve this inequality, and let's approach it the same way we would approach an equation. So that means let's distribute the 4, and then you would be left with 8x minus 12 is strictly greater than 4. Let's isolate the variable by adding 12 to both sides. When you add negative 12 and positive 12, you get 0. So then you have 8x plus 0, which is just 8x, is strictly greater than 16. Let's divide both sides by 8, and you have your solution, which is x is strictly greater than 2. There's your solution. Any number that is larger than 2 will satisfy this inequality. You know that's infinitely many solutions. Infinitely many numbers are larger than 2. But so any number that's greater than 2, 2.5, 2.3, 2.7, 2 and 8/9, 2.01, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's infinitely many numbers that are greater than 2. Any one of those will satisfy this inequality. So we solved it. The next part, let's graph the solution set. So what I want you to do is go to a number line. Okay, here's the graph. Go to a number line. And I want you to put 2 right in the middle. And then I want you to locate two numbers that are equidistant from 2, meaning the same distance. In other words, let's see, if you make this 1, the number 1 is 1 unit away from 2. That means 1 unit greater than 2 on the right would be 3. Okay? Now, you didn't have to use 1 and 3. Maybe you want to use, let's say, 0. If you choose 0 on the left, then what goes on the right? Well, 0 and 2 are 2 units apart. That means 2 units to the right of 2 would be 4. Okay? You don't have to use 0 and 4 on the sides of 2. You can use 1 and 3. You can use negative 1 and 5 or whatever. Just make sure that these numbers that are on the sides of 2 are equidistant from 2. Okay? Now, this solution set says every number that is greater than 2 is your solution. Some people use this trick. They look at this symbol and they say this is an arrow pointing in the direction of your solution set. So they say this is an arrowhead pointing to the right. So what we want to do is go to the right of 2, like that. Okay, there's the graph of your solution set. Because this inequality is strict, you're going to put a parenthesis on 2. A parenthesis right on 2. A parenthesis, okay? Interval notation, all it requires you to do is to read your graph from left to right. From left to right. Read your graph. The first thing I read is a parenthesis at 2. That's the first thing I see. So interval notation, let me write that out for us. Interval notation, right? would be the following. A parenthesis at 2, and then this goes on forever all the way to positive infinity. All right, so these are my three answers. So this is my solution, this is the graph of the solution set, and this is my solution set written in interval notation. Now, let me talk to you a little bit about this parenthesis here. The parenthesis on the 2 means that 2 is not included. That's the meaning of the parenthesis, okay? And the reason why we put a parenthesis is because this inequality is strict, okay? Had this inequality been non-strict, meaning greater than or equal to, I would have included the 2, and I would have done that by using a bracket, okay? Now, infinity always gets a parenthesis because infinity is not a real number. So infinity and negative infinity, by the way, will always get a parenthesis. So you may want to add that for your notes, all right? Always close infinity and negative infinity with a parenthesis, always, regardless of what the inequality that's given to you, whether it's strict or non-strict, it doesn't matter, okay? All right, everybody. Let's look at another example. Okay, guys, here's our next example, example 7. Solve the inequality, graph the solution set, and write it using interval notation. This inequality is non-strict. Remember that when we get to the end. Non-strict means at the very end, when we go to graph the solution set, we'll put a bracket on the endpoint, not a parenthesis, meaning we should include the endpoint. All right, here we go. I'm going to collect the variables on the left. Remember, I recommend that you keep the variables on the left side at all times. We all know that x minus x is just 0x, so then this just gives us a negative 9x on the left, greater than or equal to 32.4. All right, next I'm going to move my constant term to the right by using the opposite of subtraction, which is addition. So I'm going to be adding 3.6 to both sides. Let me make that look like a decimal point. There we go. Negative 3.6 and positive 3.6 cancel out. So you have negative 9x is greater than or equal to 36. I'm going to divide both sides by negative 9. Now, whenever you divide by a negative or multiply by a negative, your inequality symbol has to flip. So then this becomes x is less than or equal to negative 4. So be very careful to remember that because we divided by a negative, you have to flip the inequality. All right, everybody, here we go. Any number that is less than or equal to negative 4 is part of your solution set. So here's my number line. I'm going to put negative 4 right in the middle. I'll put two numbers on the side of negative 4 that are equidistant from negative 4. All right. Any number less than or equal to negative 4. You can view this as an arrowhead pointing to the left. That's the direction of your solution set. So from negative 4, go to the left, like that. Okay, everybody, to the left. Now, because this is a non-strict inequality, that means you ought to include the endpoint, which means put a bracket opening in the direction of your solution set. Not a parenthesis, a bracket. The bracket here means that negative 4 is included. So that's the meaning of the bracket, okay, everybody? That endpoint is included in the solution set. Okay, interval notation just means that we need to read the graph from left to right. Now be careful, from left to right. If you read it from left to right, not right to left, everybody, left to right. When you read it left to right, the first thing you read is an arrow that's approaching negative infinity. So then it's negative infinity that we write down first. Close that with the parenthesis always. And then the further you go to the right, you approach negative 4. So negative 4 is the last thing you read going to the right, and then that's a bracket. This is interval notation. Interval, let me write that out for us, okay? This is our answer written in interval notation here. All right, cool. Again, 3 parts. Your solution, and then the graph of your solution set, and then the solution set written in interval notation. Okay, basically 3 different representations for your answer. Okay, guys, this is going to be our last example. Same instructions. This time, notice that you have, first of all, you have a strict inequality. Okay, that means when you get to the very end, you may want to be using parentheses for your endpoints. But notice that you have fractions. We can get rid of the fractions by multiplying both sides by the LCD. The LCD here is just 5 because both denominators are just -5, right? But let's multiply by -5 to get rid of both the denominators of 5 and also the negative at the same time. So here I am multiplying both sides by -5. That -5 just divides out with that -5. That -5 divides out with that -5. So all you're left with on the left-hand side is 3a minus 4. Or you know what, you might want to keep in mind, you know what I've seen students do is they cross-cancel, or they cancel out the fraction, right? They divide out these -5s, and then after they do that, I've seen students distribute the -5. This -5 is no longer there. It got divided out with -5 here. So they both cancel each other out. So there is no -5 left over to distribute. So don't cross-cancel these -5s and also distribute -5. That's doing too much. Notice that we multiplied by a negative, so we want to flip the inequality symbol. Don't forget to do that. So this is what we have now. Let's collect our variables on the left-hand side. So I'm going to subtract 3a from both sides because subtraction is the opposite of addition. And we all know that 3a and -3a cancel each other out. So our variables just canceled themselves out and we're left with a true statement or false. Is -4 indeed less than 15? Yes, it is. -4 is less than 15. This is a true statement. We're left with a true statement. Now, I don't know if you remember a few minutes ago, you and I were solving linear equations. And we said, whenever the variables cancel, like they just did here, and you're left with a true statement, your final answer is all real numbers. Do you remember that? So our final answer here is all real numbers. All right, there's your final answer. Okay, now how do you graph all real numbers? Well, let me show you. Here's the solution set graphed, okay? So here's my number line. Okay, maybe zeros right in the middle. I don't know how you want to do this. Just put a few numbers there. All real numbers just means that you show a solution set going indefinitely in both directions like that. This is how you show all real numbers. In interval notation, it'll be from -infinity to positive infinity. Don't forget, both positive and negative infinity are closed out with parentheses. What does this mean? Well, this solution set means that no matter what you plug in for the variable here into the original inequality, no matter what you let a be, this inequality will be satisfied always. That's what this final answer means. Okay, everybody, we just went over solving linear equations. We went over what an identity is, what a contradiction is, and when you're supposed to write all real numbers, when you're supposed to write no solution. We also went over linear inequalities, strict inequalities, non-strict inequalities, interval notation, and also graphing the solution set. Can I just say one last thing before you go? You know this last example that we just looked at? Had this statement here been false, right? Like maybe -4 is greater than 15, which is not true. If you would have ended up with a false statement here by chance, your final answer would be no solution, okay? All right, this is the conclusion of this short lesson. So I hope you took really good notes. I'll catch you in the next one.